Hey, what's up, everybody? Welcome to the channel. I'm Chad, and I just wanted to take a minute and tell everybody thank you that has taken the time out of their day to comment on my social media posts and encourage me to keep doing these videos. Your support definitely means a lot to me, and it helps me to want to come out here and continue doing this, and shows me that there are some people out there that do enjoy it. So without getting too sentimental on you guys, I just wanted to say thanks for that. So today's episode, we're back on Natalie's wheel tubs for her truck. And you can see that this would be the inner portion that's cut out to go inside the engine bay. And then this would come out and extend, and this would connect to the fender out there, and your wheel's going to be in the middle of here. So the problem that you run into is when you have one piece of metal that doesn't have any shape in it down here, this material can get loose and flex. Flat sheet metal is weak. That's why on all your cars, you notice they have body lines going down the side, and hoods and trunks have shape to them. They're three-dimensional. Yes, that is for aesthetic, visual reasons, but it's also to give the car strength and to make them safe. So what we need to do here is we need to put some sort of shape in this, so this isn't just floppy. It's not going to hold a shape. And the way we do that is you're going to create some sort of a lip, some sort of a profile, some sort of a body line, and when that's on there, this becomes three-dimensional and it's strong. You can no longer bend it. And I'm going to walk you guys through the process of how I make dies and how we're going to get this lip on this piece of metal. So to put that lip or this nice finished edge on that material, we're going to go back and use the power hammer. Yes, you could do it with a bead roller and you could use some stepping dies. The problem again is bead rollers are not strong enough to shape metal. All they do is form it. They bend it. When you go to the power hammer, this material is actually being stretched into position. It's being hammered into this shape, and you get a better finished product. The panel will stay straighter, it's going to be stronger, it's going to look better. It takes a little bit more time to build the tooling, but once you have the tooling, even doing this process becomes faster than running things through the bead roller. It's just, in my opinion, the better way to create quality parts. So I'm going to show you how we start out and how we make the dies, and then I'll show you the operation of the power hammer and how this works. When you purchase this machine, it comes with a set of tool holders, and they fit inside the machine. It's a little difficult to get this one in there with the lower in place. And the upper portion of this machine is what reciprocates and goes up and down. This is basically your hammer. And this is a 5/8 wide tool holder. And you can create any custom tooling you want to hammer in any shape that you can imagine. If you can make it, this will hammer it. So I'm going to walk you guys through making the tools that go in the tool holders that are provided with this machine, and how I go about that and how it works. So I'm going to show you guys what I had to start out with. You bring your tool holder over to the bench, that's laying there, and if you saw my other video that I posted where I made basically this punch piece for the machine, I had more of this 5/8 square stock available. So the 5/8 square stock fits in these lower tool holders, and obviously it's not tall enough to clear them. And I was digging through my scrap bin, and I just happened to have a piece of 5/8 thick flat plate steel that had been torched off of something. And I had this kicking around in the scrap bin for a few years, and you know, you're never really sure why you kept something for so long until you find a use for it. And I figured that if I took a piece of this and cut it to approximately 3 inches long, I could weld it on top of the square stock. So I clamped these pieces together and I just put a bevel in there. That way I could fill it with a nice small TIG weld just to hold them together. And I could create tooling and I wouldn't have to buy any more material. If I was in a production shop and I was making a bunch of tooling and I had a customer that, you know, was paying for tooling and stuff, yeah, I could buy 5/8 bar, 2 inches or 3 inches tall. I could buy bar stock, but just for doing this as a hobby and wanting to test something out, this is stuff that I had here. And it took me a little bit more time and a little more effort, but I was able to make it work with things that I had readily available without having to buy a stick of material for one project. So once I had my game plan together, how I was going to make tools, I needed to come up, what kind of design do I want to put in here? And to do that, I have a contour gauge that you use for doing body work, or if you have a metal panel that has a curve in it, you want to duplicate that on your new one. So I walked up to the side of the truck and I just stuck this on the body line to give me some sort of a visual aid. And from there, that's how I came up with this. Obviously, it's not as extreme as the body line on the truck. I didn't want this to end up looking like a water park slide with too many complex curves in it and just being kind of atrocious, like, wow, you did too much. Just wanted it clean and simple. So this was the start to that idea. Okay, this is what I want to do. So when you get to that point, you're going to want to have a clean piece of metal. I sanded all this down to where I had a clean piece to work with, and you can use a big black Sharpie. I prefer to use Dychem layout fluid. For those of you that have never used this, don't know what it is, imagine what it smells like when your significant other is painting their fingernails. It smells like a big bottle of fingernail polish. And what you do is actually paint this on your material and give it a few minutes to dry. We'll just paint that on there just as a reference so I can show you guys. And I lost my magnet, so I'll find another magnet to show you. What I actually did to create the radius, I laid a magnet on the material and then used a fine point scribe to trace that. That gave me a nice consistent radius, and then I moved it to this point and then traced the radius here. So you would take this and, let's see, if that was here, do that, and then you want the radius here, use that. And then I took a flat steel stainless ruler and put this on there to get a straight line to know how far I needed to cut down. And then this tapered up into the top. And you can see with the Dychem on there, you have a really precise line that's very, very visible. You know, you have clean material and then all this blue layout fluid. So you have a line to follow to cut. And there's a couple ways you can go about this. If you have a really nice belt sander, you can run these flat areas up against a belt sander. If you're like me and you're kind of working with hand tools that you have in the garage, I like to take a carbide burr bit. This is wide enough to go across the whole area of material and put that, you know, grind down to your line. And then once you're close, you can move to a roll lock with some sandpaper on it. I start out with 80 grit and then go to 120. And then for the final step of polishing the dies, because the surface of these dies is what's going to get transferred onto your material. So if there's gouges and scratches in here or any inconsistencies like a bump, that's going to transfer into your material and it's going to be visible in the finished product. So then I took 80 grit on a DA sander and made some test passes with these. As I was doing my test passes, I learned very quickly just how much these dies need to be rounded here, this radius that needs to be put on them. Specifically, if you can see on this one, this die tapers down to really only about a 1/4 inch thick in this section, and I had to really round this edge off. And I had some great audio on that when I was actually using the power hammer, and for some reason I had a problem with the mic and none of the audio worked, so I lost all that. So I'm going to do my best to describe it to you now. This was my first test piece, and when you go around a tight radius, what happens is this piece is hammering down on your material, and if this is too squared off, what you run into is you can't drive a square peg through a round hole, essentially. So the square here was wider than what my radius is, so the edges of the tooling would catch on the panel and give you these aggressive tooling marks, and then it's very, very hard to planish that out once you have that happen. So on this radius here, where it is not as sharp of an angle, it didn't do it as bad. And then I realized what was happening and took the dies back out and added this radius. And then I just quickly cut out this test panel, and I made one radius here that was less than 90 degrees, and then this one here that was, you know, pretty sharp. And you can see that after doing that, it eliminated almost all of the tooling marks in the corner. It made this work really, really well. So that's the key to success with your dies, is you really have to be cognizant of rounding this off to where when you go around corners, it's gonna have enough tool clearance not to leave marks in your panel. So even though this is a 5/8 wide piece of material, really you only need the center 1/4 inch of this to do the work. That machine reciprocates at, you know, 900 900 times a minute. So it's doing 900 hammer blows in a minute. It doesn't need to be that wide. You can do a small section of it, and it's going so fast that as you're moving the panel down, it's all getting hammered enough times to blend it all out. So again, a 1/4 inch wide is really all you need on the tooling in the center, and where you've got curvature and stuff, you really need to round this off. Now, if you were doing a completely straight piece with no curves in it, this could be completely square because there would never be anything for it to catch on. You'd just be going in a straight line. But when you have to make corners with it, that's, the tighter the corner, the more aggressive that your radius needs to be for clearance here. And then I'll bring you to the next point. When you're feeding your material through the machine, you have to have a way to control the depth. If there's nothing on the back side of this tooling, you could feed the machine, you could feed the metal in too deep, pull it out, you're going to get an inconsistent line because this is going to be moving all over the place. Now, there is a generic tool holder that comes with the machine that holds a guide fence that you can use. It's kind of big and bulky, and when you're doing something this small and intricate, it's hard to use. So I took a 3/8 bolt and just cut the shoulder off of it, and you can see it's just welded onto the end of the die. So that way this is the bottom die that doesn't move. So it's fixed. And that way I have something steady and consistent to hold my material up against, and you can walk this around that and really create your profile, and it's always going to be consistent, exactly the same, and you're going to get straight lines. So
the straighter and more consistent all your lines and radiuses are, the straighter and more consistent the finished product comes, because this is what's dictating that. This is pushing up against that fence, and that controls where this is going to be hammering in and out. And that makes it come out nice. So now I've got the tooling in the machine, and you can see there's 3 set screws that hold the tooling in the tool holders. What I like to do is bottom this lower die in the tool holder and make sure all 3 of these are tight. And what you're doing is looking where the tool is in the holder and making sure that it is sitting all the way down and flat, because you don't want one of these to come loose when the machine is hammering and for this to move, because then it's going to create an inconsistent bead profile. It's going to damage your panel. And then what I do is I will run the machine down to the bottom of its stroke, and I'll just kind of snug up the clamp here, because you see there's some free play in here. This is kind of like a drill chuck, and I want to not tighten it so tight that I can't move the tooling, but I want to take all the slop out to where this is not moving anymore. And then I'm going to run my lower die up to the top one, and you can look through, and what you want to see is a consistent gap in your tooling, because I'm going to move it to kind of exaggerate things. If this is way too far forward, it's going to hammer right in this corner, and then this area is going to be loose out here. So it's going to create big flat spots and hammer marks in the material right here, and this area is going to be loose, and it's not going to be consistent because it's going to have that margin of error. So a consistent gap is what you're aiming to set up here. And you need to make sure that your tools are in line this way, because this lower tool holder can rotate, and obviously you don't want your dies, you know, crisscrossing each other. You want them on the same plane to where they're flat, and they need to be level. So taking your time to make sure that this is set up as accurate as possible is going to yield you the best results. And you want to take a piece of the material that you're using, whether it be 18 or 20 gauge, just depending on what you're working on, and you want to set your tooling gap where that material thickness is consistent all the way through. That's kind of what I use as a guide. So we're going to bump this back, and then I'll run this up until it touches, and that I'll kind of bottom this out, and that way it puts this upper tool all the way flat in the holder too, to where I know that once I'm hammering, it can't rock and move one way or the other. And then you can go through there and look and see, by using the light shining through the dies, to see if you have one spot where it's really, really tight here and an air gap here. You want to try to just make it as consistent as possible. And that's actually looking pretty good right there. So I'll go ahead and tighten up the upper. And then I'll run a test piece through here just so you can kind of see how this works. So once you've got your tooling adjusted in here and you're happy with your clearances, you're going to make sure that everything's tightened up. Again, this lower collar, I'm just going to snug up because I'm going to have to adjust this up. You cannot hammer this all in one pass. You can't just set your tooling depth to the thickness of the material and run it through. You're not going to get good results. You have to creep up on it. So I have the machine at the bottom of its stroke. Right there's the bottom of the stroke. And what I do is I'll put the material in there, and I'll run my lower die up. Right there's where it starts to make contact. And what I'll do is I'll add a half turn from there, and then I will lock this down, And we go in, what I found on this machine is half turn increments. So it takes 5 or 6 passes to get to the finished result. But when you're shaping metal, if you do something too aggressive, it's very hard to undo it. So you want to creep up on it. That way, if something starts going wrong, you can catch it before you've made your panel so bad. The other thing is, when you're feeding, especially a piece this small through here, you need to be very mindful of your fingers, because this doesn't care what it's hammering. It'll take the finger, whatever gets in there, it's going to smash it. So now you're going to want to start the machine and have it running before you feed the material in there. So you'll ramp this up. I've got the machine set to about 750 beats per minute. And then holding this up against your die hold, the guide there, you'll feed this through. And you can see it's barely starting to do anything. So now we'll raise it up another half turn, feed this through. Little more each time you see it, start take a little bit of shape. And patience is key. You half turn at a time, you're going to get better results. One thing to definitely make note of, if you're doing a larger panel especially with like the curves and bends in it, like the inner fender piece that I showed you earlier, you need to be putting some sort of an oil to lubricate that when you feed it through here. If there's no oil on the dies, the metal will actually get hot and gummy, and especially in the corners, it'll stick and it'll grab the material out of your hand, and it'll go in a position that you don't want it to be in, and it'll damage the panel. So it's definitely a good idea. Some people use ATF mixed with acetone. If you have a little WD-40, you can spray some of that on the panel just to help, and just kind of rub it in with a rag just to give it a nice sheen. That makes a big difference when you're running this through here. Another thing to note, I don't know if you guys caught that, when I was feeding this through, it started jerking the panel kind of violently. If you have your panel in there and it's not flat across the die face and it's at an angle up or down, it will make this panel jerk violently out of control, and that's letting you know that you're not holding it flat. So that's something that you get a feel for. You can also hear the machine. When you have it nice and flat, it has like a nice deep hammer tone, like a thud, thud, thud. If you're holding it off the plane and it's at an angle, it'll get a hollow, tingy sound is what I've found. So we're going to adjust this up another half turn and we'll make some more passes. So now we're going to go through and make our last pass, and I'm going to show you how I like to set my tooling height for doing the final pass on this. You run the machine down to the bottom of its stroke, and I like to take a flat piece of the material and feed it through here. And if it's a little loose, I want it to just have a slight drag on there to where the dies are going to squeeze the material in there, not so much to where they're going to, you know, stretch them out aggressively, but just enough to where these dies are going to press this in between them and planish this out really nice. So I want to take this and I'm going to feed just a flat piece of the material in this back edge, and I like to run it to where I just put a little tension, a little bit more than that. Just to where I know it's actually going to squeeze the material in there a little bit and really form it nice and planish it out. So that gap looks pretty good. I'm gonna go with that. We'll run this through there and I'll show you guys what the final result looks like with that. And again, you want to try to start the machine before you feed the panel in there. Slow, the machine working slow can put inconsistent marks in there. So when it's running and then you feed it through, you get a better result. And there you have it. That's your finished result. You got a really nice shape on there with very minimal tooling marks. You know, you can see where it hammers in this corner. You're going to get a little bit, but again, none of those are deep. You can barely feel them. So that'll polish out with, you know, some Scotch-Brite or even a piece of 80 grit on a DA. All those very minimal tooling marks will polish right out of there. And that's how you get that shape in a panel. Hope you guys enjoy.